Hello, learners. Welcome to Top Notch Online TV. Today we are going to have a chemistry lesson with me, Thaddeus Mbaluka, your chemistry mentor and your chemistry teacher. Today, I'm going to talk about the qualitative analysis of the anions. This is due to the public demand in the channel, or rather in the TV program, whereby we have analyzed the analysis of cations, but there is no episode for the analysis of anions. So today I'm going to unpack and illuminate the main concept that is required for you to score everything on qualitative analysis, especially on the part of the anion test. So wherever you are waiting for an exam, you focus on three main areas. So we are focusing on the candidates and the Form 3 who are supposed to do their mocks, or rather their Form 4 entry exams, or the Form 4 who are waiting for their mocks and also the KCSE. When you're waiting for an exam, as a candidate, you focus on three main areas. And you focus on what is tested, how it is tested, and what are the expectations of the examiner. So having said that, I want us to delve deep and be able to see which are those anions that are normally tested in an exam. It doesn't matter which exam, whether it is your monk, whether it is KCSE, but this is what in the syllabus. So let's look at the examination content. And we start by looking at the checklist for anions. Under the checklist, before I go to the analysis of this of the anions, I'll take you through what are the reagents. So that when you step into that particular lab and you are carrying out a practical test, possibly this occurs either in question 2 or question 3 of the KCSE or the mocks. Normally, tests for cations and anions have always been tested under question 2. But surprises are there. Like last year in KCSE 2022, question 2 was from organic and question 3 was from inorganic. The test for cations and anions was placed under question 3. So, but what we are sure of is qualitative analysis will feature is either question 2 or question 3. And remember, Top Notch Online TV is the ocean of knowledge. In matters of chemistry, this is the headquarters of chemistry. So walk with me as I try to navigate through the deep waters of chemistry. So the first reagent that you're going to find in your lab is lead-2 nitrate. And when you see lead-2 nitrate, you have to understand what are the anions that are tested using lead-2 nitrate. The anions that can be tested using lead-2 nitrate are as follows. We have sulfite, we have sulfate, we have carbonate, then we have chloride, bromide, and iodide. So even sulfide are there, but sulfide are not tested normally in practicals, but you're going to find it under the theory questions, whereby you have to invoke the concept of this. So literally, lead-2 nitrate can be used to test about 7 anions. The other one is barium nitrate or barium chloride. Barium chloride and barium nitrate will test for 3 anions. Those 3 anions are the sulfite, and carbonate. So we have the sulfite, and the carbonate. Those are the anions that are going to be tested using barium. Then the other one is dilute acids. The dilute acid that we use under qualitative analysis is dilute hydrochloric acid and dilute nitric 5 acid. This one is used to differentiate the sulfate, sulfite, and carbonate. So the dilute nitric 5 acid can be used to test for carbonate, hydrogen carbonate, or sulfite. Then we have aluminum foil and sodium hydroxide. This one is used to test for nitrates under the Davada alloy test, as you're going to see later in the analysis. Then we have wooden splint. You have heating followed by use of a wooden splint. This one can be used to test for the gases, either that extinguish or that, of course, relight. So here we have the test for carbonates, because when you heat a carbonate, you give carbon dioxide, which extinguishes a burning splint. We have nitrates, whereby when you heat a nitrate, some nitrate like those of potassium and sodium, they will decompose on strong heating to give oxygen gas, which again relies a glowing splint. The same with manganate ions and chlorates. Remember, some of these things you may not have done them in school. But remember in Form 1, when we are preparing oxygen gas, we prepare oxygen gas by heating potassium manganate 7, by heating potassium chlorate. So when you heat a solid and you get a gas that relights a glowing splint, that is automatically oxygen. It means whatever you have heated can be a nitrate. Whatever you have heated can be a manganate 7, like potassium permanganate 7, it can be a manganate ion. It can also be a chlorate ion. Then the other one, we have the use of acidified potassium manganate 7 and acidified potassium dichromate 6. These ones are used to test for sulfite ions. Then we have the use of chlorine water and a starch. And this one is used to test for bromides and iodide. Let's now navigate deep and look at how to simplify the test for anions. Here I'm going to use a special technique called the Octopus technique. This is a special technique that helps a learner to summarize concepts, to simplify it, and be able to present all that information in one page. So as you can be able to see in the projection that is on the screen, let's move on to the screen now, whereby we have the Octopus flowchart for qualitative analysis of anions. Using the Octopus technique, I have summarized on how to analyze the anions. So let's move together. We have first of all, we have the group comprising on 7 anions, as you can be able to see here on the screen. We have sulfate, carbonate, we have sulfate, sulfite, carbonate, sulfide, chloride, iodide, and bromide. They are 7. All those 7 can be tested using lead nitrate. How? If we have a sulfide and you add lead nitrate, you're going to see a black precipitate. That tells you that is sulfide ions. You may also get a white precipitate, and this is the one that is mostly tested in exam. When you get a white precipitate after adding lead 2 nitrate, that tells you we can have a sulfate, a sulfite, a carbonate, and even chloride and bromide. Those are 5 ions that give the same observation of a white precipitate. So when you add lead nitrate, you get a white PPT. That tells you that could be a sulfate, a sulfite, a carbonate, a chloride, and a bromide. You can also get a yellow precipitate. When you get a yellow precipitate, that is iodide ions. That is iodide ions. Now, you can see the test for iodide and sulfide can be identified just using one range, that is lead nitrate. But now with the others, we have 5 ions that are giving the same observation. So under the concept of qualitative analysis, we usually start with one agent that gives you so many ions. Then you go on using elimination method to identify each of them. So let's see. Although sulfate, carbonate, chloride, and bromide give you a white precipitate with lead 2 nitrate, let's see now, how can you differentiate the 5 ions so that finally you can identify each of them? You can add dilute nitric 5 acid or dilute hydrochloric acid. When you add those dilute acids, you are looking for bubbles because sulfite and carbonate will give you effervescence with a dilute acid. So when you add dilute HCl or dilute hydrochloric acid and you see bubbles, that tells you there is a sulfite or a carbonate. If there are no bubbles, it means now the sulfite and carbonate are not there. So what is present is the sulfate, the chloride, and bromide. And listen very clearly. This is the catch, and this is whereby many students get confused. Whereby on adding HCl, of course, you expect bubbles. So many students, if they don't get bubbles, they say sulfite and carbonate is absent. The role of qualitative analysis is to identify the cations and the anions present. Therefore, if you have added an acid and there are no bubbles, you had started with lead nitrate, you got white precipitate. You said this is sulfate, this is sulfite, this is chloride, there could be bromide or carbonate. Now, if you add an acid and there are no bubbles, you eliminate there is no sulfite and there is no carbonate. So what is present? It is the sulfate, it is the chloride, and the bromide could be present. Now, let us see, how do you differentiate? How do you differentiate now the sulfate, and carbonate? To differentiate the sulfate, and carbonate, you can add barium nitrate or barium chloride. Why? This one, as I said previously, this one is used to test for sulfate, and carbonate. But now when you add it, already you are remaining with sulfate, chloride, and bromide. When you add barium chloride or barium nitrate, you get a white precipitate. That tells you that is a sulfate. If there is no white precipitate, it is chloride and bromide which is present. So in that kind of a scenario, now how do you differentiate chloride ions and bromide ions? You add chlorine water to bring about the concept of displacement. So if there is bromide ions and you add chlorine water, the chlorine will displace the bromide ions to form bromine liquid, which you dissolve in the resulting solution, giving bromine water, which appears as a yellow solution. So you can say yellow solution formed bromide ions, no yellow solution chloride ions. Then this one is not, of course, cleared or rather explained in the flowchart. So you listen and you add it to your notes. That is, how do you differentiate now the sulfite and carbonate? Such that if after adding lead nitrate, you go to white PPT and you say this was sulfite, carbonate, chloride, bromide present. Then you added an acid and there were no bubbles. There were bubbles, then you say this could be sulfite or carbonate. How do you differentiate sulfite and carbonate? You do so by adding either acidified potassium manganese 7 or acidified potassium dichromate 6. So if you add acidified potassium manganese 7 and the acidified potassium manganese 7 changes from purple to colorless, then you say sulfite is present. If you add acidified potassium dichromate 6 and the acidified potassium dichromate 6 changes from orange to green, then you conclude it is sulfite which is present. If the orange acidified potassium dichromate remains green, then you say a carbonate is present. The same way with manganate 7. If acidified potassium manganate 7 is not decolonized from purple, then you also say carbonate is present. Now, it's also important to note that we don't mark any answer. If you're adding an acid, you're looking for bubbles or no bubbles. Don't tell us no observable change. Don't tell us no change. That is very much important. Now, those are the issues of concern. But assume after adding the nitrate, there was no precipitate, or rather no white precipitate. Then you could have said the sulfate, sulfite, carbonate, chloride, even bromide is absent. Then now let's look at the other analysis. Let's look on the what? On the right. Not on the right, on the left part of the screen, we have nitrate. How do you test for nitrate? There are two ways of testing for nitrates. We have the brown ring. We have the brown ring test, and we have the divider's alloy. So the brown ring is what you have been taught and is captured in most of the books. It uses concentrated sulfuric acid. I can tell you that there is no exam that you'll ever do that uses either concentrated sulfuric acid, concentrated nitric 5 acid, or concentrated hydrochloric acid. So we only use dilute acids. So this one of use of a brown ring test is only applicable in theory. And how can it be tested? You can be told a student from Alliance High School collected a sample of soil from the school farm. Then the examiner will ask you, describe how you can confirm if the soil contains nitrate ions. How do you go about that? The procedure is you put the soil in a test tube, or rather in a beaker, add distilled water, filter. Then to the filtrate, add freshly prepared iron 2 sulfate followed by concentrated sulfuric acid. Formation of a brown ring confirms presence of nitrate ions. I've said, you can be told you have collected a sample of soil from the school farm, then you're told to describe how you can confirm that soil contains nitrate ions. Then you're going to say, put the soil in a beaker, add distilled water, filter. To the filtrate, add freshly prepared iron 2 sulfate, followed by concentrated sulfuric acid. Formation of a brown ring confirms presence of nitrate ions. Then we go to the divider's alloy. This one is not captured much in most of the books that is available. But of course, this is what you're going to find in an exam, in a KCSE exam. Which one? The divider's alloy goes like this. That you're going to warm. You have the test solution. So that test solution, you add a sodium hydroxide. You start by adding sodium hydroxide, then followed by aluminum foil. Then you test the gas producing a red litmus paper. So there is an omission that I want to add. You are saying you start by, you need to add sodium hydroxide. You need, first of all, to the test solution, you add sodium hydroxide to the test solution. Then you warm. Then you add aluminum foil. Of course, you get the test solution, add sodium hydroxide, followed by aluminum foil, and then you warm. Then you test the gas produced using a red and blue litmus paper. So this is what is expected. And these are the marking points. Bubbles of a colorless gas with a pungent smell, identifying the smell of the gas. Then changes moist, red litmus paper blue, that's another marking point, and blue litmus paper remains blue. So normally, this question is usually being given, or rather has already been given 2 marks. So the marking points are as follows. And it's very easy. Even if you don't know you don't need even to know the name of this this test. That is called the Davada's alloy. What you really need to understand is just one thing, that wherever you're going to see sodium hydroxide followed by aluminum foil, sodium hydroxide aluminum foil, you know that is Davada's alloy. So I'm saying the marking point here is bubbles of a gas, tick, have a mark. With a pungent smell, tick, have a mark. Red little paper changes to blue, tick, have a mark. And blue little paper remains blue, tick, have a mark. That is the marking dichotomy in that particular question. And that is how you're going to score 2 marks. Then now, let's go out to differentiate now bromine and iodine, because these ones are normally tested whenever the examiner can bring a test involve iodine or bromine. So how do you differentiate the bromine and iodide ions? So this one, you can simply add lead to nitrate. So when you add the nitrate, if it's bromine, you're going to get white precipitate. If it is iodide, you're going to get a yellow precipitate. Then you can also add chlorine water followed by a starch indicator. The reason why I'm saying there's a rationale to differentiate bromine and iodine. Bromine solution is yellow. Iodine is brown. Those colors are easily confused by students. So sometimes to differentiate them, you can be told to add chlorine water, whereby they're going to displace either bromine or chloride, then followed by a starch indicator. So if it is bromine, the chlorine water will displace bromide ions to form bromine liquid. The bromine liquid will dissolve in the resulting solution, forming bromine water, or rather bromine solution, which is yellow. So the solution changes to yellow. So you say yellow color, or rather yellow solution formed, rather no blue color. Yellow solution, no blue color. That's bromide. Because remember the reaction between starch and iodine, we have the starch-iodine complex, which is blue. In biology, people, they call it blue-black, but in chemistry, we insist on one color. So don't talk about blue-black in chemistry, it's blue. So when you add chlorine, water followed by starch, remember, first of all, there are 2 specific observations we're expecting. Because here we are looking for displacement. If it is bromine, the solution will change from colorless to yellow because of formation of bromine liquid, which dissolves to form bromine water. Then we are going, because the bromine does not react with starch, then there will be no blue color. So the 2 observations there is yellow solution, yellow color, no blue color, or rather no blue color. Then we have with iodine, we are going to form a brown solution, and blue color will also be observed. Then you confirm iodide ions are present. And that is the end of our lesson today. Keep it here at Top Notch Online TV, the ocean of knowledge, whereby we continue to unpack and desimplify chemistry in a paragonic manner. And don't forget to subscribe to Top Notch Online TV. Give us a like and a comment, and of course you can ask any question. Until next time, bye-bye.